Can you connect N8N AI agents to everything, every tool using MCP? That's the question we're going to answer today. Everyone in the AI community has been talking about MCP and the power of it. And to be honest, it has huge potential of being the new big thing adopted within N8N and the AI and automation space. Imagine having the power of N8N triggers, being able to activate anything at any time, but the flexibility and access of MCP to all your business data and tools. It's way easier and faster to set up. You'd have already access to 1,800 tools and software that you can connect your AI agent to. And the best thing is you don't even need to explore the API. It's all done on your behalf in a unified way. And you don't even need to wait for N8N to update their tools. The changes will automatically appear. And if you are a beginner, or you miss these new updates about MCP, or you don't know where to start or what it is, don't worry, this video will be your complete guide. We'll start with the basics. We'll run through exactly what MCP is and the concept behind it, why it has the potential to be a powerful combination alongside N8N, and we'll even show you step by step how to set it up yourself and 3 examples of this combo in action. And we'll always show the problems you face along the way. Let's get started with a quick demo of what you can achieve with MCP. So the first example we can do with MCP is scraping a web page. When you traditionally do this with N8N and there's no inbuilt tools node with our AI agent, we'd have to set up a HTTP request, define the body, define the headers, etc. With MCP, we don't need to do that. I've asked it to scrape zapier.com. It's the agent with a very minimal prompt. You're a helpful assistant, find the tools available, find out which tool is best for the job described by the user, and use execute tool. So super simple prompt. I've just said scrape Zapier. It's listed the tools from Firecrawl, so it's shown exactly what tools are available. So it knew to call that, and we've got scrape a single web page, crawl multiple pages, and various other endpoints or parameters that we'd usually have to set up with a HTTP request. We don't have to do any of that here. It's called the execute tool and actually scraped Zapier, all in natural language, and it took about a minute to set up. We can do other things, which we'll show you in the run through, including finding a local restaurant using Google Maps and acting as a travel agency AI assistant where we search the web. Those are some really simple examples of what you can do with MCP. Now we're going to run through exactly what it is and why it's so powerful, or could be so powerful, combined with N8N. So Model Context Protocol, or MCP, was launched by Anthropic last year, but it's really starting to pick up steam now. And you can just think of it as directly from their website, a standard for connecting your AI assistants like ChatGPT and Anthropic to the systems where your data lives and returning that data in a standardized way. It's been compared to a USB-C port for AI applications because a USB-C port connects to all of our different devices. In a similar way, MCP helps connect our LLMs or AI models to the data we want, and doing that in one single standardized way. And why is that super important? Because it helps us build agents and complex workflows on top of our LLMs. And it's even more powerful when coupled with N8N. So Model Context Protocol, or MCP, if you distill the words in that, you kind of get the essence of what it is. So we're connecting different AI models to context. All of the LLMs and AI tools we use, we're actually able to connect them to all of the different services and tools we use in our business. So think of it like ChatGPT connected to your Slack account, connected to your Google Calendar, and actually able to take actions with those. So it's a unified way for AI or LLMs to interact with tools. To all the tools we use in our business and more, things like web search, Airbnb, scraping websites, even N8N itself, we can connect to our chat environment or our LLM environment and take actions specifically on those. And the reason it could be so revolutionary, it's a unified way of doing so, which means it's going to be a lot less work. It's going to be standardized, the data that goes to and from our client environment, like our AI or LLM, where we query from, through the server, which essentially are just set up to give us access to the data we want access to. So this might be a server set up specifically for Google Calendar, and that would be called the Google Calendar MCP server, through to the tools that it's going to use. So the calendar server would connect to our Google Calendar and have access to all of the different functions that a calendar would need, like creating events, deleting events, etc. But most importantly, we're able to send that in a uniform way and also receive the data back in a uniform way. There's an open source repository of all of the MCP servers, which you can go to here. And if you scroll down, it shows all of the different tools we're able to connect to. So some key examples here: GitHub, Brave Search, which allows us to search the web, Google Maps, Google Drive, Slack. And then you can see there's also a ton of third-party servers, including things like Apify, where we can use 3,000 different tools, Firecrawl, where we can scrape websites, and then an even bigger list of community servers, Airtable, Calendar. All of these we can connect to and effectively treat them like additional tools in our N8N environment. So within each of these servers, which allows us to connect to the data we want, like Slack, Calendar, etc., each of those have query parameters, or what they call tools, that we can enable our AI agent to interact with. So for example, if we're interacting with N8N itself, we're able to list our workflows, create a workflow, update a workflow, just to name a few. With Slack, we're able to post a message, get all our messages. And for example, we could even do things with websites like Airbnb, where we can search for accommodation and even book accommodation. So everything you can normally do, MCP servers have the ability, or will have the ability soon, to enable an LLM to take that action for us. And the MCP itself just unifies how it's done and how that data is passed back and forth. So you're probably wondering at this point, well, I've used N8N tools agents before, where we can actually have an agent that's connected to all of our different services like Slack, Google Calendar, web search, a ton of these different things. How is that different with MCP? Well, there's two key differences. The first is the structure and the way we interact with it. So if you were setting up, for example, a tool for a calendar agent, which I've shown in a previous video, you would have our calendar agent up here with some memory connected to a chat window. And we'd connect it to 4 different tools, for example, that would execute different functions of Google Calendar. There's no ability to connect to a single calendar node and execute creating events, deleting events, updating events, and getting events all in one node. It actually requires us to separate it out into functions or actions and have 4 separate nodes there. We also have to prompt it in a very specific way. So in our tools prompt, we might say, okay, for creating an event, you have to pass these parameters. For deleting event, and from my experience, you have to be really specific about what parameters you're passing, or this will fail. However, with an MCP server, we're effectively not connecting a tool for each function, but it's a tool for each tool. So we'd have one calendar booking agent like we had before. We would actually be just connected to one MCP server, which is a Google Calendar server, or connects us to our Google Calendar data. And within that, we'd have list tools. And that Google Calendar server would have access to all of these different tools or functions of create event, delete event, update event, and get event. And that would come back in one single call. The calendar booking agent then has enough context to understand which tool it should utilize, and we can pass that directly into an execution action through the Google Calendar server. So you can see how it has the potential to simplify the way in which we use these agents and the tools and data it is connected to. But there's 2 other tools that are set up that are going to really help us reduce the amount of work we need to do, and those are list prompts and list resources. Now, they're not set up for every single MCP server, but as we go on over time, if this becomes a standard, then this will be really, really powerful, because at the moment we're having to write these long prompts that are really specific. If there's a unified prompt that we can just hook into inside the MCP client, so this would be the Google Calendar client, for example, and so with this, that it would enable the AI agent to understand, okay, I'm trying to create an event. What prompt is best to create an event? And if we go into this server specifically, the Google Calendar MCP server that somebody has set up here, you can see that we've got underneath the prompts that it will return here, analyze schedule. So it has a prompt built into this server that's able to analyze the schedule and generate insights about the calendar, including upcoming events. And it returns a structured prompt for LLM analysis. So without any prompts in this AI agent, we could ask it to find our events. It would list the prompts, list the resources it has, and list the tools that it has access to. And it would dynamically be able to work out from the prompts that, okay, I'm able to analyze a schedule here, but I'm also able to create an event. Because if we go back to the tools, we've got a create event tool in here, and it tells it exactly what parameters it takes, title, time, etc. And those will return in the list tools. It's then able to execute the tool for us. So you can see that if working correctly and standardized, this would massively reduce the amount of work we needed to put into for every single tool we connect to, and would save us a lot of time for our business. Now, the second reason that this is really powerful in combination with N8N and makes it simpler for us is that when we connect using an N8N tools agent, it's great when we have access to the tools already. However, when we want to connect to external sites like Airbnb, N8N itself, any random site, we're then forced to go through the HTTP request or connect to the API's route. If you've ever tried to do this, you'll understand that each server or each service that we're trying to connect to has completely different API documentation, which means when we're trying to fill out the HTTP request itself, it takes a long time. It often has different parameters going into the request. We need to understand the endpoint or URL. We need to put in headers. We need to put in a body, all in different formats. However, not with MCP. If done right, it has the potential to standardize the way we connect to those external services, which means we're not reliant on N8N updating their tools. We can just connect to an open source server. Say in this instance, Google Calendar was not a built-in tool in N8N. We would be able to connect to the Google Calendar MCP server, list all the tools available, which would come back with these 4 event types or functions or actions we can take. Or as another example, we might be connecting something like Brave, which is a web search server that enables us to search local websites, but also just perform general web searches. And you'd see if we were to call the list tools function, or the AI agent would call that, it would effectively return consistently for every single tool what the name is, the description of what it does, which is then fed back to our AI agent, and then the schema or the data that it needs to send to perform that action. So whether we're contacting Google Calendar, Brave Search, Airbnb, Stripe, it all comes back in this format, and you can see that that makes it easier for the AI agent to interpret how it should send data and what data it should send. Combined with what we said before, the MCP server's ability to list prompts and list resources, you can see this has the potential to massively unify the way we connect to external systems. We no longer need to look at API documentation, unify the way data comes back to us, so we receive the data in this format, and also unify the way context is stored. Context is really important for LLMs, and MCP ensures that that context is retained at all the different stages. So instead of a complicated HTTP request with different parameters, but we're able to one-to-one connect, for example, to the Brave tools here, dynamically pass in which tool from the AI agent we want to run, and then also define automatically the parameters it's going to send. You can see this is much, much simpler than a HTTP request, and that's the second reason why combining this with N8N is super powerful. The final thing before we jump into a demo and show it in action is a quick comparison of what this is like. So you probably are aware of OpenRouter and how that unifies the way in which we connect to different models. You can think of MCP as a unified way to connect to all of our different context, hence Model Context Protocol, or all of our different business data. It unifies the way in which data is sent there and data is received back. So now let's jump into a demo, and I'll show you exactly how to set this up from scratch. And if you're completely new to N8N and have no idea what's going on, I'll link you to my full masterclass for N8N right now. So we're going to set one up from scratch now, and we're going to simulate a travel agency AI assistant. So somebody's asked the query, I want to plan an 8-day trip to Asia in April for my family of 4. We'd like to stay in a safe city with good access to public transportation and local attractions. And they've also said 20 to 30 degrees centigrade, so fairly warm. So fairly warm if you're not familiar with the centigrade system. So around 68 to 78 Fahrenheit. Now, in my head, we're needing 2 key things here. The first is ability to search the web for safe places or safe cities, as well as the local attractions and information about public transport, and then also some way to access weather information. So that might be web search, or we might have a separate weather server specifically dedicated to that. So we're going to go through and set this up, but the first key thing you need to know is that there's no inbuilt MCP node in N8N as of yet. However, as this expands, I imagine it will become an inbuilt node inside N8N, which means you have to be self-hosting to be able to install this node because it's a community node. So there's this node here, N8N nodes MCP, which is created by Nerding.io. And I can see it being part of N8N's core library very shortly with the ability, with the capability set expanded. Inside GitHub, it shows you the different installation guides, but we're going to run through that in a simple, straightforward manner. It tells you how to set up credentials and gives you an example of the node being used. So what we're first going to do is go down to your settings down here, and we're going to install the community node. So we'll go to community nodes, and you'll go to install up here, and you're going to type in N8N-nodes-MCP, and we're going to tick the box here and click install. I won't be able to install it here, but yours will go and install it because I've got it already installed. So that's the first step. You're then going to go to a blank, and we've done the first step. The second step is that we're going to identify which servers we want to use. Like I said, each MCP server is dedicated to a specific set of tools. There's no MCP server that connects to lots of different tools yet. So we're going to go back to the list of servers here. And the first thing we're going to do is look into these servers, and we know we're going to install some or need some web and local search capability. So we're going to install Brave Search. So if you click on Brave Search here, it tells us that it's got 2 tools, a web search which executes web search and a local search which can search local businesses. So this one looks good. You're going to need to sign up to the Brave Search API account, get an API key, and there's a free tier available. If you scroll down, you can see the different installation instructions for Docker or for npx. This might seem a little bit complicated, but I'm going to show you how to install this. And in the installation instructions, it gives us an example, so we'll follow that step by step as well, so you can understand what's going on here. So they are installing the Brave Search server as well. So there's 2 things we need to do, or 2 key things. The first is install the MCP server on our self-hosted server. So I self-host through ls.io. So I'm going to go to my ls.io server, and you might be on Render, you might be on Railway. They'll have a similar path for this. The terminology will be the same, but to access the terminal will be slightly different. What you'll do is you'll access the terminal or the shell, and it will open a window like this. And you're going to type in npm install -g, and then you're going to go back to the server you're trying to install and copy and paste this npx method. So model context protocol server Brave Search in this example. And we're going to run that, and that's going to install the Brave Search server on our self-hosted server, which will contact the tools on our behalf. If you haven't installed this before, this might run for a few minutes. And also it might throw an error around installing npm first, in which case you'd run this command, sudo apt install node.js npm, and that would enable the installation manager to be installed before this, so it doesn't throw any errors. So run this command first if you get that error, and then run this one second. But it's important to note this is specific to the server for Brave Search only, the MCP server for Brave Search. If you wanted a different one, say to install GitHub, you go to the GitHub, you'd scroll down in a similar way. It has all the tools, etc. here. And then it gives the @ name here, so server GitHub. I also wanted one for weather, so I've gone away and found one for weather. So I'm going to do npm install -g and then a server weather here. And sometimes you're going to hit snags like this. It turns out this server weather you can only install via a different method. So it's not accessible because we're not locally hosting here. So what we're going to do is go back to our AI agent, actually remove the need for weather. Web search should give us enough to just test this and get an approximate view on weather anyway. We're not looking for a specific week or up-to-date weather information. We're looking for generic. So now we've installed the Brave search on our server directly. And we've also installed the MCP node. We can open the MCP client tool by typing it into the nodes bar here. And there's two options here. We'll explore both of them, but one is an AI agent tool. The first is it as a node itself. And we're just going to list available tools here. So that's going to open up the MCP client. And what you're going to do is go to create a new credential. And there are two types of credential here. We're just going to talk today about the command line or the standard input output. And they're super easy to install. And if we go back to the documentation, it tells us exactly how to do this. So we're going to create multiple MCP client credentials. So one for each server we're using. In this case, we're just using Brave Search. And we're going to take these values. Again, it's just npx-y and then the server name, exactly like we did before when we installed on the server. So we're going to copy and paste that. In the command, we're going to write npx. And here we're going to write -y and then the server name, exactly like we did before. So we've got the command, we've got the arguments from our server here for Brave Search. And we take that just from the arguments here, -y, name of MCP server. What we have to do now is put in our Brave API key. So we copy the environment variable, we go back to our N8N, we make sure to put Brave API key equals, and these servers will all have different names for what they call their variable. And then we go to our Brave search where we've set up an account, we get our free API key, we copy that back and we paste it in here. I'm going to change that to fixed so nobody sees my API key, and we save, and that should set up the MCP client for that specific tool. It's a one-to-one interaction between that tool, i.e. Brave Web Search, and this server that we've set up. If we now rename this, again, MCP client Brave, and we test that step, that was on the list tools operation. So it will return all of the tools that we can use for Brave Search. And what we have here is in the return are all the different tools. So you can see the name, the description, and the schema that needs to pass. So if we come out to the node, type in MCP again, and now let's execute a tool. So actually we want to execute the Brave Web Search. So let's just drag that in. And you can see the tool parameters are query, count, and offset. Query is the only required one. And we're just going to add the manual trigger. So we're going to add in the parameter of the query because that's the only required one. And we're just going to search the web for latest AI news. And the tool name here we're using is Brave Web Search from the left-hand side. So once we execute that, we can see that we've listed the tools here. And now we are executing a specific tool and it's returned in a consistent format, the type of data and the text. So that is how you use it as a node. But what we don't want to be doing is passing in every single tool name that we want to use. We want to create more complex queries where our AI agent decides dynamically which tool is best. And that's really the power in N8N and combining this with N8N. So what we're going to do is open up the AI agent node and we're going to connect this to a chat window. And we're just going to get rid of that. And we'll do the usual stuff like connect to our model, the model of our choice. So open router through OpenAI here. We're going to attach a simple memory that's connected to the chat trigger input. And now is where it's slightly different. We're going to connect to the MCP client tool. And you can see this will pop up with our different credentials here. So we're going to use the Brave credential. We're going to set the tool description automatically. And then we've got the different options here. So we're going to list tools first. And then I'm just going to add a prompt inside here. And it doesn't necessarily need a prompt. It will work it out itself. But the more specific you can be, the better the results are going to be. So we're going to find the tools available from the user query, work out which tool is best for the job, use execute tool, passing in the correct parameters. And we could be more specific, saying use Brave list tools. But again, we want to keep this open-ended and see how it performs first. So we're going to connect it to another MCP client tool, and we're going to allow it to execute a tool, but what we'll do is let the model define the parameters. And also we don't want to express which tool, we want it to pass it in this dynamically. So we'll have from AI, selected tool to execute. And we'll call this execute tool. So now we have the prompt set up, we have the list tools, and we have the execute tools. And we're just going to get rid of this user query because the user query is being received in from the chat input. So the difference between using the node directly and connecting to a tool is you need to enable in your environment variables in your server to allow community packages as tools. So what we're going to do is take this statement here, N8N underscore community packages allow tool usage true. And we're going to again open up our server or your own server environment, and you're going to head to the environment variables. So in ls.io, we've got this update config, and you can either update it in your Docker Compose directly or your env file. Don't share any of your keys in your env file. So you can go down to the bottom and you're going to add this line here, N8N underscore community packages allow tool usage. And in your Docker Compose, it's going to be in this format. In your environment variables, it might be something like this with an equals instead. But once you enable that, you need to update and restart your server, and that should allow you access and stop causing any errors when you're connecting to your different tools. That's the only difference between using it as a node and using it as an AI agent tool. We just need to enable that on our server. So first, let's just chat to it and ask it what tools it has available. And it should know to call the list tools. And it's come back with the following tools: Brave Web Search with the description and the parameters. So exactly, you can see that because it's returned in this unified, consistent way, which it would with any tool, not just Brave Search, it's really given us a view of what tools are available. So let's see how it performs with our query. And hopefully it will list the tools and then execute the web search to find out this information. So it's listing the tools. And you can see that we've had an error, but it's actually come back with some response. And we can see in the logs here that it has executed the tool, and it's sent this query: best safe cities to visit in Asia in April with good attractions, 20 to 30 degrees Celsius. And it's failed to connect to the correct credential there, and that's why it's caused an issue. So we'll just run that again to make sure it's not the LLM answering and it's actually the tool response that's feeding in that additional context. So it's listing the tools and it's now executing that query. And that's successfully executed the tool. So it's now working out what response it should give us in the chat window. And you can see it's given some really concise information about different cities in different countries that we can visit and given us specifics around our query. So it's decided from our query what things it needs to search, looked at the tools it has available, and therefore executed the relevant tool for that. When you connect this to multiple tools, you can see how powerful this can become. If you connected it to something like Airbnb, it would even be able to look at relevant accommodations in those cities and suggest some options for you. However, the limitations here at the moment are that this is fairly new protocol. So although it says 1,908 different MCPs, and this is growing by hundreds by the day, by the way, it's not necessarily always the services you want to use. If we want to use something like Airbnb, it might not have, okay, Airbnb is an example that has it, but if you wanted to use a different service, it might not have access to that. And we are relying on people creating servers in a specific way so that we can connect to them. So right now, the capability is limited, but you can see if this is adopted as an approach, then we could connect to hundreds of tools with a really simple prompt and pass values dynamically from our AI agent. It becomes even more powerful when you have the MCP tool list prompts, because you'd be able to have your basic prompt in your system message, but the list prompts would supplement that prompt with context about that specific server. So for example, going back to our Google Calendar tool, list prompts would tell us, this is the prompt you need to use, AI agent, to most effectively use these tools to take this action. So you can see, instead of writing a detailed prompt ourselves, it will become a standard way of pulling in the context of a good prompt to search X tool, like Google Calendar, But even if we search a query like what prompts do I have available, it understands it needs to list prompts. You'll be able to see that it's searching the list prompts, so it understands what tool to ask about that. But you can see if we go into the tool itself, failed to execute operation, MCP error, method not found. So there is yet to be a standard for setting up these MCP servers. If all of these had list prompts as a method, then this could be a really powerful feature and people will start building these out. But until that point, we still have to input our own prompts. So it makes it a little more difficult, which to me tells me until this technology is a bit further along, this kind of thing is not ready for production use versus the very structured inputs and outputs of the traditional N8N tools agent, where we can define all of those inputs and outputs and write our own prompt. But you can see that this can be really powerful as it develops over the next few months. And all of these things are moving so quickly. So I imagine we're going to see this MCP node and tool node be integrated into N8N directly soon, as well as the number of MCP servers grow and the number of official ones grow to support different actions. So it's a really, really exciting opportunity to potentially connect everything to our AI agent through a few different tools and simplify our workload for our business and being able to access our business data massive. So I'm going to do one more quick example to show you the difference between doing this through MCP and doing it just straight through HTTP requests to show that it's easier. So we're going to do a restaurant booking or finding a good Indian restaurant local to you. And we know from doing it before that we just copy and paste this and the command is npx and then we have -y and this, and that should set up our argument credentials. We'll rename that Gmaps. So don't forget to restart it. We come back, we open it up, ask it what tools we have available, and it's now going to search our Gmaps list tools. And when you're setting this up, remember in the environment variables, we need to add our Google Maps API key or the name of the variable before our API key here. And then we'll save that. And you can see that that's now successfully run. So we've got the Maps geocode tool, but then we've also got Maps search places, details about a specific place, elevation, directions between 2 points as well. So you can see that if this was a HTTP request, then, and we wanted to use all of these different endpoints, that we might have to do 7 different HTTP requests. So we might have a request like to an endpoint that looks similar to this with lots of different points. And that's going to be quite complicated to set up and quite time consuming. Whereas here, where it's listing the tools for us, we can then just go and execute and it will determine which one's the best for our use case. So as an example here, let's go and execute tool 2. Let's change it to our Gmaps. These are the same parameters, which again makes it really unified and easy. And here instead, we're going to paste in our query and let's see if it can determine which tools to use. Okay, so it's successfully executed. However, I have done something wrong with the API key somewhere, so it's not executing correctly. But we can see inside the logs that it would have called or did call the maps search places with the query Indian restaurant, and it's broken down the location for us and given us a radius automatically. So without having to set up all those different API endpoints, it's queried the correct thing. So really, really powerful. Just need to make sure I set up my API key correctly next time. And we're just going to do one more example to show you the power and speed at which you can set these up without having to go search API documentation. So we've got scrape web page here. So Firecrawl is a service that scrapes different websites. What we're going to do is set it up in exactly the same way. We'll make sure we've installed it Firecrawl on our server. So we'll copy the command from the Firecrawl MCP server. And then we'll make sure we've set up the correct credential. Again, we need a credential per MCP server. So we'll go to Firecrawl, get our API key, copy that back, save that and rename. Same again with execute tool. We'll just change the Firecrawl. Everything's defined already, so we don't need to set up any API requests again. Really simple, super quick. Hope you're getting the idea for how many tools you can connect here and how powerful it is with the unified input and output. We'll ask it what tools again. And we've got the scrape. which scrapes a single web page. We've got the map, we've got the crawl where we can crawl multiple pages. Again, all of these would need separate parameters in an API request. Some of them would go to different endpoints. So if we were setting this up from scratch, it'd be lots of HTTP tools. Here, we can just get the AI agent to interpret what we want. It would be even better if they had prompts in list prompts, but a lot of these tools are not set up like that yet. And when you start to build out these queries, so for some reason it's returned an error, but not an error that it didn't run, an error that there was no content available from that homepage. So I've asked it to go again on Zapier.com, and actually it's returned all of these different line items for Zapier.com's or Zapier.com's homepage. So to go back to the question, can an AI agent connect to everything through MCP servers? And is this the future of N8N and the tools agent? It's hard to say at this point. At this point, none of these are production ready tools. In an ideal world, we'd have a setup similar to this, where we have an AI agent, and then all we connect to is a list of tools. So one tools agent that says, okay, you've got all of these servers, access to web search, WordPress, Notion, Calendar, Stripe, Airtable, whatever we set up. It would list out all the functions of all of those tools. Our query would then be matched to, okay, I want to update my calendar, so I'll use the calendar tool. And that would then send the correct parameters to the execute tool, which again would only need one other tool, but could pass in the credentials for each of these servers dynamically. That's not something that's possible at the moment. That would make this the ultimate scalable tool. The other factor in deciding this is the lack of development, which is increasing in these MCP tools and making them standardized. So we already touched on the fact that the list prompts is often not comprehensive or doesn't exist at all as a method for these tools. If we had a way to pass that prompt context back into our AI agent, then it would enable us to connect to all these tools and prompt them in the right way rather than having to write a long prompt with context ourselves. If MCP were to become the industry standard, then I think N8N would move towards this. And the number of MCP servers, the official ones, massively increase in growth. And that would mean that potentially one day, perhaps soon in the future, we'll be able to connect to every single tool with just a few nodes through our tools agent.